is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, good evening, everybody. Welcome to SkyTour LiveStream. It is me. I think I'm the Mark guy, Mark D'Antonio. Nice to see you all here. I am, of course, joined by Daryl Mason, who is always he's with us all the time. And Daryl, how you doing?
Not all the time. I'm good. How are you? Hello, everybody.
I'm doing good, thank you. Doing very well.
I should say howdy.
Yeah, you're a good howdier. So I see we got some early birds. Native NC, nice to see you. I guess stands for North Carolina. And then we had Cosmic Rays with us, Donald Kunzer, and Michael Hedrick joins us, and Sam S has joined us. Dagger Spells, hey, haven't seen you in a while. It's so good to see you back again. And we're going to start off with something that was requested by Daryl. That's this object here. It's called the Butterfly Cluster, and it's actually very pretty. We'll zoom in just a little bit. This is our live view, our live low light view. We have several views. We have a low light view. This is so we can see what the telescope sees, but enhanced, like night vision. And then we drop out of this view to go to our deep sky view, which is where we actually take a real exposure and start to see it in all the splendorous colors that may be in there, if it's a nebula or what have you. It's really great. Now, Daryl, you also wanted to see M7, right? Oh, there goes a satellite.
Yep.
That's a Starlink satellite that just went cruising through. Yeah, and so that's
It's not dark out there yet.
no, not quite. In fact, for those that want to see what it looks like out there right now, let's bring up our AllSky camera, and you can see right here. Okay, you can see the Milky Way. It's not quite dark yet. Right, here's the sunset light over there. Interesting, the clouds are black against the sky, white against the sky here, because this eastern side here, if you look over at our what's our compass rose here, east is this way. That's the direction of Phoenix, 75 miles away.
While you're there, can you turn on the chart?
Yeah, sure.
That was something else. Okay, they don't mark it. Venus and Mercury are both now visible over in the west-northwest, low after sunset. Mercury will be going away pretty quick. Venus is going to keep rising for months to come and be putting on a show as it slides to the south later this year. Presently it's up there with the star Regulus, it and Mercury both. The bright star Regulus in Leo, which is going away now. Mercury is on its way down already, I believe, and Venus, if you have a good view low in the west-northwest, you should be able to see Venus now.
That's actually excellent. We're going to be digging into some of the Milky Way objects tonight. Summer sky approaching here. We are going to look over here in Corona Borealis to do our checkup on T Corboreal, a red giant paired with a white dwarf star. The white dwarf is gaining mass from the red giant through their common center of rotation, and the white dwarf is approaching a critical mass. And every 80 years or so, the gas that is deposited on the surface of the white dwarf by the red giant becomes deep enough and hot enough that it reaches fusion temperatures. And so runaway fusion takes place on the surface of the white dwarf, but the mass never exceeds the magic number that would cause the white dwarf to go into what we call a type 1a supernova. So this particular star will go back to being a white dwarf with a red giant once again for another 80 years. So I think that's pretty cool.
Papa Tom's wife is in the
see
chat.
that. Well, thank you so much, Papa Tom's wife, for delivering this message. I know that he was having some difficulties. My sympathies to you, both from a personal level and friendship level here, too. So sad to hear. So sad to hear indeed. But you were right. Tom really enjoyed what we do. But thank you so much for coming in and saying that. And I'm so sorry, hon. So sorry indeed. So we'll dedicate tonight's Sky Tour to Papa Tom. I think we should, at the very least. But thank you for coming in and letting us all know. Boy, you know, Papa Tom was a fixture, you know. He would come in all the time and say hello in our chats and hang out with us and say some cool things. Really enjoyed his company on our chats and our stream.
Yeah.
And he was a heck of a model maker too, actually. And I know that because I've been a professional model maker for decades, and I always admired his work tremendously. So we definitely we'll make a special show for Papa Tom in the future.
Sorry
Showcasing
for your
some of
loss.
his work. Yeah.
This was Tom.
Yeah.
Time is creeping up on all of us.
Yeah. Michael Hedrick, that's such a kind gesture. And I also want to thank you for the last donation you gave to us. That was really unexpected, but wonderful. Thank you so much. And he is now donating in Tom's name. And Mrs. Tom, if you can privately send me your address, any monies that we get, I will send to you tonight, okay? All right. Whatever it is, we'll make sure you get it. It's much deserved, as Michael Hedrick says. So, if she's still listening, you can find me at skytourlive.org, and my email's up there. It's contactskytour@gmail.com. So we will definitely take care of you in any way we can. Okay.
I saw a flying saucer model he did once.
Mm-hmm. Picking up a cow?
Yep.
Yeah. Yeah. Absolutely beautiful. Thank you, Michael. You're incredible. I want to show some love for Michael Hedrick. He's been standing by us and other people here, and as you can see, his true humanity and personality shows with his comments. So show that guy some love. He is definitely deserving of that. I hope tonight we don't have to worry about too much of the thunderstorms that are all around us out there, but we'll do our best. This is the butterfly cluster, and we're going to do a 15-second image of the butterfly cluster, and we'll note that as butterfly cluster. Okay. Let's yeah, it's gonna be pretty.
There's the butterfly.
Yeah, I'm gonna do it without the oh sorry, that was the test object earlier, the trifid. So here's an example of, it looked like this earlier just a moment ago, but I want to show you what it looks like when we process it. Now it may have a little, yeah, there's some color in here. The butterfly cluster has this beautiful red star, probably a red giant. And these are our curved peaks, red, green, and blue. And I will move this black level up to near the peak to make the background as dark as you can see. And you'll notice there's some red around this. This is probably not sunset light, but probably red nebula, red diffuse nebula in the region. And we can back out a little bit. And definitely red diffuse nebula here and here. Really pretty.
You're not far in the sky from center of the Milky Way.
No, I'm not. We're actually quite close to Sagittarius A star location.
And that is a very nice red star.
Yeah.
I see the butterfly.
Is it right here?
I see the butterflies. Yeah.
It looks like an 8.
The two curved lines of stars there to the upper right of where you are, a little bit. Two little fine lines of curved stars. That's the butterfly's antenna.
Right here?
No, farther up. To the left a little
These?
bit.
Oh, these?
Yes.
Oh, okay, yeah.
And
There's the body.
His right wing is pretty prominent there on the lower right.
Yeah.
Two big loops. You said you saw figure 8.
Yeah,
I guess that's
here.
his left wing.
And this is the right wing here.
No, that's his. Well, his right wing on our.
Or are these the antennae?
Those are the antennae.
These two fine lines of the antennae.
Yeah,
So
or
the
you
body
might
is
say
here.
I don't know. They look like antennae to me.
Yeah, they do. Either way, it's a pretty cluster.
It is that.
Yeah.
There's two big curls of stars to the lower right, and that's his, what I would say, well, it would be its left wing, but it's to our right, so I'd say it's the right wing. Then the other wing is to the left. Maybe not quite as distinct. Izabela's here.
Yeah. Okay. This is really pretty. Tiffany's here. Hello, Tiffany. How are you? Long time no see. It's so good to see you. How is Michael doing? I haven't seen him and heard from him in months. That's because it's really long hours at SpaceX that he's putting in there.
Yeah. What's his handle? Calibos?
Yes. That's Michael, yeah. Tiffany says hi.
Yes.
Okay, so I'm gonna poke this up. I'm gonna actually, first of all, back out, show the whole frame. Look at all those nebula in here. Let's see what else is here. We're gonna do a punch up overall and see what we got. Yeah, look at that. Lots of diffuse nebula in here. Now we're still getting some light from the setting sun, all right, but it's going away. He's asleep there, but asleep. All right, so here we can see just little remnants of the sunset. The Milky Way is gaining prominence and brightness in this exposure. We turn on our constellations. You can see we have Cygnus the Swan, Lyra here. Okay, we have Vega and Chiliac, and I can't remember this star's name at the bottom in Lyra. And then we have Altair, Deneb, and Vega, and these are the summer triangle.
Don't forget Terrazed.
Yeah, Terrazed.
Yeah.
Yeah.
Right next to Altair, there on the right.
Yeah, right there. Yep. Yep.
And there's Arcturus, and
Yeah. So
to the left, Corona Borealis. To the left of Arcturus, upper left is Corona Borealis in that view.
yeah. This is Deneb to Vega. This is Vega to Altair. And Altair back to Deneb. This makes the summer triangle right here, guys. That's what we look for. Summer triangle. And Daryl talking about Arcturus. That's right here. Inside the square. A little off.
And if you draw a line from Arcturus to Vega, Corona Borealis is about 1/3 of the way from Arcturus to Vega.
That's correct. And Corona Borealis is right here, inside that circle.
Yeah, and the brighter of the stars you see to the left of the brightest, that's Alphecca.
This
Also
is
known
Alphecca.
Yes,
Right
also
there.
known as Gemma. And then the star right under the second O, I believe, is Well, that's the second star of the crown from the left side, and then T Corona Borealis is going to happen just to the lower left of that star.
Right there, that's right. So, and we're going to go take a look at that. That's right about here. Okay, in this particular location, right about there. And that's where we will see yeah. Well, anyway, so that's cool. Hello, Tricia Ferreira. Hey, Carl Becker. What's going on? Nice to see you guys. All right, let's go back to our image of the butterfly that we are taking, the butterfly cluster. Oh, look at that. That's surprisingly beautiful.
Yeah.
Well, let me just pull up a little more detail.
Another nice red star down at the lower left edge.
Oh, yeah, that's correct. Well, let's see if we can identify those. I will bring up our annotation, and let's annotate by looking at what's nearby. Okay, there we go. That lower left star is Hipparchus. Looks like an 86751. This one is Hipparchus 86327. Yeah. So that's what those two stars are. And then, of course, this is the butterfly cluster, NGC 6405. And we'll save the annotation. Save the image with annotation.
Seeing the Hipparchus stars reminds me, I read somewhere the other day that the Gaia satellite was evidently hit by a micrometeorite.
Ah. Wow. Hey there, Lucky Luke. Good eye from Australia. How you doing? Nice to see you. We have several people from Australia that join us on a routine basis. This is nice to see you, Luke. What part of Australia are you in? I just did a talk down in Perth at a conference down there. It was through Zoom, of course, but they are working on having me come down. And, you know, if you're part of that group, then maybe you heard me.
Be cool to get to go to Australia.
Yeah, I can work out where I'm going to put the fourth telescope. We want to have a southern hemisphere scope in as soon as we basically can, because that's just, I got to see the southern sky, the Magellanic Clouds, and he's from Sydney. Okay, very nice. Other side of the continent from Perth, but okay.
Trevor at Astro Backyard on YouTube, he recently got to visit Australia.
Oh, did he? Yeah. Luke used to live in Perth. That's like saying I moved to Connecticut from, say, California. It's quite a distance. Okay, this is great. This is more than enough for this image. It's a gorgeous image of the butterfly cluster. So the first click saves the FITS file. That's an astronomical file format that you can use to get the raw data if you're so inclined. I do it. Izabela does it. Some other people do. And then we'll save it exactly as seen. And what that is that gives us a PNG file. And if we click on it, this is what you get. And this is free. You can download this, enjoy it, and use it as your backdrop. Put it wherever you like. It's all yours to use for whatever reason you wish. Okay, so now we're going to leave this cluster. And Daryl, you said you had another one you wanted to look at?
M7.
All right.
Oh, excuse me.
It's okay. I'm coughing too. I'm not sick though. I've been working without a vocal cord for about 8 years. The other one works, but I'm missing one.
Pardon me.
No, no worries. D Smith is with us. Hey D, how are you? So nice to see you. Jeremy B's with us. Hey Jeremy. Okay. let's go to our planetarium. And if we go look at, let's do this here. It's M7. Okay. That's Ptolemy's cluster. We've looked at it before. And we'll go there. And we're going to tell the telescope. The telescope is that little plus, that crosshair right there. This square represents our field of view. And if we zoom in, you can see the writing. We are 1.5 degrees across in the field, and we are 1 degree tall. So it's a wide field telescope, and so that's our field of view. So I've just told the telescope to go there. So if you watch here, okay, it's kind of hard to see because it moves very little to get to Ptolemy's cluster. But look at that. That's Ptolemy's cluster, and that's going to be beautiful too. Yeah, excellent. So right now we're going to look here because it's saying searching. It's looking for a guide star. When it finds a guide star, our telescope that's right here on the back of the main telescope is going to start guiding, and you'll see numbers start showing up. There they are. We're seeing percentages of correction. And now what I'll do is we'll do the same kind of thing we did before. We'll do a 15-second exposure. There we are. And we'll come out of our low light mode and go into deep sky mode. And I'll bring up the live stack buffer. Explain that in a minute. That's our previous cluster we just looked at. Okay, we're going to clear it. Yeah. So what's happening now is we're taking an image, then taking a second image, aligning it with the first, and stacking it, and stacking it, and stacking it, and stacking it. We create an image sandwich. And this image sandwich allows us to literally remove much of the noise that you get with digital photography. And look at this beautiful cluster, and look at the dark nebula associated with it. This
looks like
is
a little red nebulosity going on to the upper right too.
Yeah, I have a feeling right here. That's actually a globular cluster.
Oh, is it?
It is. And,
very red.
Yeah, but let me color correct it. Yeah, okay, so it's probably distant and reddened. Let's annotate. It has the old annotation, but let's. Oh no, it doesn't. How about that?
Nice.
That's actually interesting. I didn't expect it would have the annotation. I thought I had to make it happen, but maybe it's because we're connected here, so it knows where it is and the annotation comes up automatically. That'd be cool. Wow. Yeah, Ptolemy's cluster. We'll save this image with annotation here, like that. And now the image with all this information on it is saved out there. This cluster here is the NGC object I was just telling you about. NGC 6453, and that is, where is it? It's in the list here. Or is it 6450? No, 6453. Here it is, right there. There it is. That's the globular cluster right there.
Yeah.
Oh, look, we got a visitor spider right there.
Wow.
Hi, what's that? Oh, wait, that's not a spider. That's a grasshopper or something crawling on the infrared. Oh, interesting. Yeah, well, you get all kinds of things in the desert. All right. It might be it's not a scorpion. They don't have antennae. Okay, this is pretty. Look at this. So we correct the color, and then what we can do is we can play with our settings to actually give us better resolution. There we are. Better detail. And this is now called Ptolemy's cluster. That's PTOLEMYS cluster. Look at that. Yes. I didn't save it, so do so. Okay, I can do it anyway. I can save that.
Uh,
And then save that. What?
that's nice.
Yeah, I'm going to back the black level off a little bit because we have to get more data. Or actually, you know what I'll do? I'm going to do this. This is the mid-level. This is the bright whites and so forth. If I bring these down, believe it or not, everything you see in there are stars. It almost looks like we've taken a photograph or are taking a photograph of a wet driveway, you know. But we aren't. This is a live image. Izabela says, "This is scary. What is that monster?" That monster is probably this big. It's probably a little tiny grasshopper or some type of creature attracted to the infrared light on the camera we're using to illuminate the telescope. C&D boy, how are you?
Sam has a question. I think you could maybe answer better than me. He had two questions. He says, "What are the scope controls on the right-hand side of the screen?" I said, "The camera controls," and he said, "Are those camera controls different from what they used to be?" I do see that feature just below the middle with the stop sign.
Yeah, I'll explain that.
I don't remember seeing that before.
No, I'll tell you exactly what's going on. All right, thanks for that question. Sam, as you know, and most people that don't, this is our telescope controls, north, south, east, and west, and this is the telescope computer access. Here's the telescope computer itself. These, of course, are the views into the building. Don't worry about this guy. He's some ignorant guy who pretends he's an astronomer. When it's up, this is our stacking window where we're creating the image sandwich. Okay, the more we stack, the clearer the image becomes, the more detail we get. So now, to the other side now. Let's actually get to the other side because that's the one you really want to talk about. We'll go through these in a little bit of detail. First of all, these are the camera controls. This is the most important item here along with this one. Exposure and gain. Gain is how sensitive we're making the sensor. It can go up to 350 plus, and it's an arbitrary number that when you start experimenting you find that certain cameras have a range that are perfect for exposing. I use 200. The ideal one for this telescope camera system is 100, but I'm using 200 because I want to make this a faster set of exposures so we have a little more sensitivity, and if there's any noise we can get rid of that kind of in this system here and on the fly. Okay, now down here this is called a histogram, and this here, if you notice, if we click that, this is going to make this very bright and we'll see what data is hiding in the background here, right? And this is the one that you're noticing that's new. This is a telescope control like this one. For the next telescope mount, we're probably going to get rid of this and go only to this because we want to be able to control what we see. I may use this in the background, but then I'll get rid of it because we won't need it after the first time it's set up. But this will be the controls to move the telescope around. We can do everything here that we can do over here. And so because this is connected to the telescope now, this means that there's features that are automatically activated that weren't before. And so like if I were to bring up the annotation again with a new system, I have a feeling that we're going to get it right away because it's going to know right where it is at all times. So we'll get a very quick annotation. We won't have to do what's called a plate solve, figure out what we're looking at in the sky, although the system can actually do that. And many times we will do that. Okay, this is the focus control system here. And these are miscellaneous image controls and a few other things. All right, so it is different in that this was not there before. All right, and And so I actually brought it back so that we can activate again some of those other hidden features that happen automatically. Meanwhile, we've got 23 exposures here with 5 that have been rejected. Now, what does this mean? I'm using what's called the full width half maximum filter. What the heck is that? Well, if you can imagine, the telescope moves because of wind, and it could make your stars oblong and squiggly. Well, we don't want that. So if it comes in above a certain amount, it'll be an oblong image. So this was 8.77, this was 8.56. All the rest are lower than that. So you can see that we're only including the good exposures in our final image sandwich that we're making. And this way we get perfect exposures and perfect stacks of all those exposures. Because it only takes one bad exposure to ruin the whole stack. And we're not going to do that anymore. So this filter keeps us from ruining it. And I have it set to 8.03. So this was 8.52. That might have made a slightly oblong star. Nah, I don't want it. So as you can see, we've got really nice stars here. So we'll go back to our histogram. That's working fine. This is nice. Let's see what it wants to set it to. Oh, look at that. I'll come back just here, really brighten it up. It almost looks like a tangle, like it's not real, but it absolutely is. Think about this. There's tens of thousands of stars just in this view. It's very possible that we're looking at planets in the view. We just can't see them, right? And this is interesting. Izabela, that nebula to the upper right, that's actually a globular cluster. Let me show you. If we zoom in, you can see that's actually a globular cluster. And that's actually becomes obvious when we do our annotation. We turn on the annotation, it's NGC 6453. And if you look down our list here, 6453 is a globular cluster.
Can you open Stellarium and find that? See how far away it is?
Yeah, I was actually going to do that. That's a good idea. Daryl has good ideas. Okay. So here's Stellarium, our live thing. Here's NGC 6453. It's reddened quite a lot. So it's 37,000, almost 38,000 light years away. And it's a halo object, so meaning it goes all the way around the galaxy, orbiting the whole galaxy, but plunges through the disk at certain points, and then plunges back up through the disk. So sometimes they probably could shed stars as they go through because of gravitational interactions, or gain stars as they go through. So that's kind of interesting.
If that's 38,000 light years away,
Yep.
Since we're looking roughly in the direction of the center of the galaxy, that's got to be clean over on the far side of the galaxy from us.
Which just explains why it's so reddened. And that's the other thing, too. And hey there, Timothy, Timothman. Probably likes the Mothman prophecies.
Oh.
Yeah. So when we see a reddened cluster like this, it's worth discussing why they get red. Okay. First of all, dust is existing in the interstellar medium. Here you see dust. This is dust. Tendrils of dust created by countless millions upon billions of supernovae, and this was dust that was created in the outer atmospheres of red giant stars, which is a process that is well known to occur in red giants. And the dust is liberated to the interstellar medium if the star goes supernova, or if it makes a planetary nebula where it sloughs off its outer layers. We'll actually see this dust go out into the interstellar medium, but nothing to stop it. It just keeps going, all right? And that's what we're seeing there. But dust also has another property. It tends to scatter high-frequency light. Now, what does that mean? Well, we can look right here on Earth to see what that means. When we look at the sky during the daytime, it's blue. Well, the sun's spectrum is red, orange, yellow, green, blue, indigo, and violet. And the blue light is the higher frequency light. So in our case, the molecules in our atmosphere scatter the sun's light and the blue part of the light. So everywhere you look in the sky, it looks blue during the day. That's called Rayleigh scattering, and it's a well-known effect. Now, it only happens because the molecules are scattering the high frequency light. Water vapor doesn't do that. Clouds are made of water vapor, so they scatter differently. They scatter using something called Compton scattering, and so that actually scatters all of the sun's light. So that's why clouds effectively look white when they're not like laden too much with water and look gray. All right. So puffy white cumulus clouds are white because of the Compton scattering, but the sky looks blue because of Rayleigh scattering. So now that we know that molecules and particles of dust in the atmosphere will scatter high-frequency light, now we have a clue as to why this very distant globular cluster seen through lots of dust is red. It's red for the same reason the sunset is red or the sunrise is red. We're looking at the sun through more air around the curve of the Earth, and therefore much of the blue light is removed from the sun's spectrum that's getting to us, so the sun looks red. In fact, the sun is almost white. How about that? All right. And so this globular cluster certainly isn't reddish in real life. The stars are going to be whitish, a whitish color. But because of the scattering and because of all the dust between here and that far 38,000 light-year distant globular cluster, the cluster's going to look more red. It's called interstellar reddening. When I was getting a degree in astronomy, we calculated interstellar reddening for different clusters and associations of stars, because you have to do that before you can adequately start to detect its spectral class. Right? You need to do that first. And then when you study the spectrum, you can actually correct the spectrum for the reddening that occurred. So that said, this is why clusters look red when they're farther away. Has nothing to do with nebulae. Nebulae glow red for a very different reason, and that's what makes astronomy interesting. Nebulae glow red because hydrogen atoms in the interstellar space are ionized, and so that causes the hydrogen to glow red ultimately. All right, so there you go. So that is a quick explanation, and I'm going to save this now as Ptolemy's cluster. There we go. All right.
So what does the dark nebula below the cluster look like to you? I see almost like a dog or some kind of an animal running to the right.
I do, with its ears like a dachshund flailing in the wind here.
maybe a rabbit.
Oh yeah, I can see
rabbits
that.
don't have pointy tails.
Yeah, they don't have long bodies. Well, they have long bodies depending on what they are. This could be a rabbit. I mean, it could look like a rabbit. Yeah. Hey, Fantasy. Hey, James Hyatt. How you doing, man? Nice to see you. Sorry I didn't notice you when you just came in. Right away. Yeah, there we go. Okay, this is good for Ptolemy's cluster. See, it's amazing what you find, when you look at in regions of the sky that don't appear to have too much going on, especially in the summertime sky. So this image has now been saved, and again, this is the image that you're going to get up on the server. And when I say up on the server, I mean free. You can go and take this image, and it's right here at SkyTourLive.org. You head to SkyTourLive.org, and you scroll down, and you'll see instructions how to get to here and see this. Now, other people will put in the address. Actually, Daryl just did it. This is the address to the server where all of our images land. This image is probably already up there, so it'll be there very, very soon if it's not there already. Fantasy, I know you told me where you are in Arizona, and I can't remember, but I've been noticing there's a lot of storms in Arizona right now, and I was trying to do this stream in between potential storms, and I think that we're good for a little while here. Yeah, because it looks like right now it's over Mesa.
Yeah.
And,
Fantasy's in the Mojave in California.
oh, okay. Yeah. I'm looking at the transition here, and I will go and look at our AllSky, but I have a feeling that it may shut us down. But that said, let's go and try and get to something else I wanted to look at. We did Daryl's 2 objects of interest that he wanted.
Thank you for humoring me.
Of course.
Hopefully people enjoyed what they saw.
Oh, it was beautiful. Beautiful gems.
Pretty pictures.
Beautiful gems. Let's go take a look at our AllSky and see. Okay, here's the clouds here. This is in the east, right? And this is going to be encroaching on us slowly. And what we're going to do is we're going to go up and we're going to be looking right around here in just a moment and look at something we haven't looked at for quite some time. And that's going to be a nebula, one of those glowing nebula that I talked about. And it's a nebula called the Omega Nebula. So we'll back out here of Ptolemy's cluster. You can see.
Also,
go ahead.
Also known as the Swan Nebula.
That's correct.
The one I call the Duck Decoy Nebula.
Decoy Nebula, upside down, yeah. Okay, let's do this. Okay, we got our telescope computer back. All right, we're going to center up the Omega Nebula here.
I suppose a swan is more elegant than a duck decoy,
I guess so.
but it's still upside down.
Yeah, and now we're gonna go here. I'm gonna get our 1 second low light view going again, and there it is. There is the Omega Nebula and the Starlink satellite. Okay, so there's the Omega Nebula telescope heeding all the commands. And what we'll do is we're going to swing the telescope slightly to the west. All right. And slightly to the north. Now this is about what you'd see in like a 6 to 8 inch telescope. Maybe this much, maybe a little less. All right, so in say like a 6-inch telescope, I'll show you what you might see. You might get, let's see, maybe, depending on where you are, you might get something that looks sort of like this.
And a 6-inch from the dark sky? Nah.
No. Like depending on where you are, if you're in like because not everyone, nearly no one is in a dark sky, so they might see that. But if they're in a dark sky, they might see a cross between this and that previous one in an 8-inch. That's what I think. What do you think?
I think you'd see, even in a moderate sky, 6 inches probably about like that. 8-inch you'd see more.
Well, I had a 8-inch, and I never saw any of this stuff out here. All I saw was this and a little of that. I could not discern that this was a dark nebula here. So, kind of tough to see. Well, dude, now let's do this. Let's do a 20-second shot here. And I think our focus is still good here. 20 seconds. There we are, off and running. You can see by our nice progress bar over here. Okay, it's right here. There's the progress bar. And we'll come out of low light mode, go into our dark sky mode, and you'll see the previous object there. Beautiful Milky Way. We're going to clear that. And the next image to come in will be of the Omega Nebula.
Carl Becker has a question you could answer.
Okay.
Oh, that's nice.
It is. Let's color correct, and then I'll get to Carl's question. What did Carl? Okay, Carol. How many images are normally processed, and if there are more, is it better quality? Yes. We did. I've done the most I've done in here is something in the order of perhaps 80 images, and if you do 25 images, then the quality will be twice as good when you get to 50 images. That's a rough rule of thumb. What's happening is, I'll show you by zooming in here. Okay, we've got 3 images stacked, but look at all this stuff in here. You see all that modeling? That's noise. Noise from the digital process, especially at 200 sensitivity. Of that 200 sensitivity makes more noise. If I did 350, this would be even noisier. These faint stars might not even be visible until we brought in maybe 40 images, maybe somewhat less. But basically, what we're getting now is we're getting this nebula, and you'll notice that it's actually very, very detailed. Now, I'm going to come over here and move us over a little bit, and I'm going to take our black level, that is to where the black starts to encroach, off the peak. Okay, see this white line? This is the average of the red, green, and the blue curves. So when we do this, we're lining up the curves under each other. The colors changed more to what they should be, which is this. And now that white curve is the average. So we want to stay to the left of that peak, because if we go too far over, watch what happens. Okay, we start to eat up our data, and it'll start getting darker. All right, you'll see here in just a minute. See what happens? We're losing some of the data. So we want to stay to the left of the peak. All right, that's the most important thing. And basically, if we put it to where it wants it to be, this, you see, gives us the most nebula, the most bang for the buck. And I can actually drop that out of the way. All right, and let me move this out of the way. Okay, so you can actually see the image in all its glory. Isn't that pretty? Now, with our previous camera that we used, we could not see all this detail in the Omega Nebula. All right, we saw like this. We didn't see all this faint detail out here. This camera is actually tuned specifically to this telescope focal length combination. All right. Claudio Ramos from Chile is with us, and he says, do you think plasma seeding and magnetospheric modification is visible? I don't think so. I think we would need a different telescope than that to see that here.
I have no idea what he's talking about.
He's talking about processes within the nebula.
You say so?
Yeah. So, let's see here. Let me show some more. Okay, I can't show it. All right. So this is the Omega Nebula, and it actually is just a gorgeous nebula. I used to just not look at it because it was boring. I was never excited by it. But then when I started looking at this nebula in detail, I started to realize that this nebula has its own share of just incredible data in there. Very, very impressive. So I just wanted to show it. I had to show this again. Look at all these billowing wisps of cloud. Really stunning. Let me actually do one other thing too. Let me go back into enhancement, and let me enhance those billowing clouds a little right here. Watch now. Look how much sharper they all look. Look at that. That's an additional process I added to this to give us more detail, called the unsharp mask. Look at that. Really pretty. And we never knew about this. I'd never seen this before. You know, this is all dark nebula, by the way, in here. Stuff that's, in other words, think of this as laying over this nebula behind it. Okay, so this is a big tongue of dark dust. You can see fragments of it sticking out here. This was all lost to us with our previous camera. And I will go back to our histogram here and try to punch this up a little bit to show that. Okay, so this is a temporary punch up. You can see now the little filamentary structure and how this is a tongue sticking over a brighter part of the nebula, making it look somewhat darker. But this is a tongue of dark nebula that's here in the foreground, and the nebula is behind it. You can see this. You can see this as a continuation of a billowing cloud that goes all the way around, and then down here, and this is in front of it. See that, guys? And that is the kind of thing we see in the universe. Remember, it's a three-dimensional universe.
Looks like you have some reflection nebulosity over on the left-hand side.
Here.
Yep.
Yeah.
Big blue color to it.
Yeah, and we would see that, and we see some here too. You know, and that's the other thing too. Again, I hate to harp on that, but with the previous camera, we couldn't see that because the camera wasn't specifically tuned to this telescope focal length. But now it is, and we get to see more than we've ever seen. And I'll just drop this back down a little bit, and I'll increase our angle of attack on our peak to help do that. And then I'm going to do another color process, because as the photos come in, the color processing will change a little bit. And so now you can see this blue, as Daryl was telling you about, very, very clearly. You can see a little here. That's just beautiful. But I hope you guys see what I'm talking about when I mention this dark tongue here coming down. This is sitting on top of this nebula, which is behind it here. So it's actually behind it. Okay. So that's what's pretty cool about seeing this like that.
If you look up toward the top above the nebula, there's like a dark streak running across to the upper left. Thin dark line.
Are we looking?
No, higher up. Right there.
Right
Down
here?
a little. Yeah, right there. See that dark line?
Yeah.
And it looks like it keeps going farther to the upper left.
It does, doesn't it?
It's just a wisp of dark nebulosity, I suppose.
Yeah. Now, notice how this looks a little redder than this. Well, believe it or not, these are the same color. The trouble is, this is saturating the sensor because it's actually very, very more dense with hydrogen atoms that are being ionized and glowing red. So the red color does get pushed out sometimes. If we go way down here, all right, you can see that it's turning redder, and you can see more detail in here. All right, see that? So it's not as white. And if we go even further down, you'll see that as well. I'm going to dock our histogram back up with this and bring this up a little higher. And
Mark, would you excuse me a moment, please?
sure, go ahead.
Yep.
And now I'm going to come over here, and I'm going to take this down even more. Here we go. Pull it way down. Okay, so you can see now that the color in here is showing up a little better, but it looks dimmer. So we have to try and find the happy medium. So what we do is we let it figure out where it wants to go. And that usually gets better and better as we stack more objects. Now, right now we have 27 stacked. So now the amount of noise is significantly less. So when we zoom in, you'll see that it looks significantly better in here without a whole lot of that noise. The star images are slightly non-round, and I think that's because we should probably do another refocusing, because wherever you go in the sky, you should refocus many times. Okay, so this is Omega Nebula, and we're going to save it with 29 and save it exactly as seen. And then when we get to 30, we'll save it again and move on. Let's go check out our AllSky, make sure we're not being encroached. Yeah, this is coming in. That's rain in there, so we're going to have to maybe do one more object. Okay. I do not want to end up having rain cause an issue. To that end, I'm going to bring back the telescope, gesture us over. There we go. And that's 31. We'll save here. Save exactly as seen. All right. And come out of here right away. Come out of the stack. Go back to our low light. Pull up this. Okay. And back out a little bit. And we're right in the neighborhood, so we'll do this object here. It's right nearby, we might as well. And this is going to be the Eagle Nebula, otherwise known as the Pillars of Creation. You'll see the telescope just move up just a little bit here to get to it. And you'll see the pillars right there. Well, you don't yet, but I will. I did push tonight. I really did want to get a stream in tonight. And I got to cover up the telescope before the rain reaches us. So we're going to do that. All right. Okay, so this is the Eagle Nebula, where you've known as Messier 16. It's also known as the Pillars of Creation. You're familiar with it because of the Hubble Space Telescope made it famous. James Webb has continued to make it famous. And we're going to do a 25-second set of stacked images on this. And our previous image that we saw was the Omega Nebula. So beautiful. Okay. We can actually clear this now, and the next image you'll see is of the Eagle Nebula. By the way, Mr. Django, I don't think I said hi to you today. That's Steven Smet in Belgium. Nice to see you. Here is the Eagle Nebula, and you can see this central portion, and this is actually how small the Pillars of Creation are. You can see them right there in the middle. Okay, so if we zoom in a little bit, it'll be a little noisy because we only have one image stacked so far. But the pillars themselves are... Welcome back, Daryl.
Thank you.
The pillars are inside this box. Right there. There is the main pillar right there. Secondary and a tertiary pillar right there. Right?
I see an eagle.
Well, it is the Eagle Nebula. That's right. And we've color corrected. Yeah, and so let's see here. Let's try a little noise subjugation here. I'm gonna pull that down a little bit. Here it is. Look at that. And we only have 3 stacked, but it's actually got a lot of detail for 3 that are stacked. 3 stacked images. Technically, I should be focusing again, but because of this encroaching storm, and we're like right about here. Let me bring this up. So we are literally right about here, and that's heading toward us. We don't want to have anything to do with that, so I am going to make sure that we protect our optical system. Alright, so 5 exposures stacked right there. By the way, there's a lot of fires in Arizona right now, so there's the images aren't the best they could be because of the fires.
Fires everywhere right now.
Yeah. Hey, Judy M.
Last week we were getting smoke from Canada and the Pacific Northwest, and we have 4 or 5 fires have started since then here in Colorado.
Wow.
So now the smoke here is coming from Colorado.
Yeah. Judy, I'm sorry that you joined us late. This is the last object, and the reason is because of in our AllSky, this is heading our way. As you can see, it's a major storm system, and I'm a little nervous about that because I got to make sure that everything shuts down well. So I'm going to save this as it is right here. We are literally doing this in between the storm systems. Jessica, how are you, Jessica? S.
It looks nice. I see the
This here. The ferry. What is that called?
yeah, the ferry. Yeah.
Yeah.
I was wanting to call it the hood ornament. I always think of it as the hood ornament.
It does look like that. So we have the
Or
pillars
like
of
an
creation.
Oscar award or something.
Oh yeah, we have the pillars here, and then we have this guy right here. This is another feature within the Eagle that we've never really seen before, and again, until this camera came along that we put in and tuned to this specific telescope, and that's actually called the Ferry. It's a feature within the Eagle Nebula, and again, these take center stage, the pillars of creation. Let's see if we can zoom in a little more now. Oh, that's looking pretty. Look at that. Just
Ray
drop this
says
down.
we need to take a look at T-Core Bore before we leave.
Yeah, I don't think we're going to get to.
I noticed recently that Space Weather has a T-Core Bore watch.
Mm-hmm.
If you go to their page, their front page, it's near the upper right.
Yeah.
Says T-Core Bore watch, and it has actually dimmed lately. It typically is 10th magnitude, and it was down to 10.4 last night.
Okay.
Maybe that's a sign.
Yeah.
I know that's what made them think it's coming now. Anyway, it was. I think they said in the past they see a dimming before the nova goes.
That could be possible. The accretion disk around the white dwarf could be thickening, and if the white dwarf is on our side, it could actually cause the overall luminosity to drop a little bit. The stars are orbiting each other. Okay, yeah. 13 images.
Before we go, I'd like to talk about something for just a moment.
Yeah, you better do it now because we're going to be shutting down here shortly.
It ain't that close. Go to Stellarium if we're done here.
We're not done here yet, but go ahead.
Okay. Well, can you open it up some? Can you go to about 2:30 or 3 in the morning?
Oh, time-wise?
Yes. If you can't do that, that's okay. I'll just tell people.
We are locked onto something right now, okay? But
All right. Well, never mind. I'll just mention it in passing.
okay.
Uh, Folks, an interesting thing is about to start happening. Jupiter moved from Aries last year into Taurus this year, and Jupiter is presently between the horns of Taurus the Bull. Uh, Mars is about to join Jupiter. Mars is approaching Jupiter from the west. It's moving a little farther east every night. And starting about the 8th, I think, Mars and Jupiter will both be in the horns of the bull in between the two. And on the 10th, they're going to be close. They're going to be closest on the morning of the 14th of August. It's the sort of thing you have to go out about 3 or 4 in the morning to get a good look at. But Mars and Jupiter are going to be just 3/10 of 1 degree apart. That's just over half a lunar diameter apart inside the horns of the bull, and should make quite a sight. And not that I'm an astronomer, I'm not an astrologer, okay, but I just, when something like this happens, I always have to wonder, what would an astrologer make of Mars and Jupiter in close conjunction in the horns of Taurus the bull?
Mm-hmm.
That must say something. I have no idea what. Okay, go back. Sorry.
It's all right.
But it'll be quite a sight.
Yeah.
Jupiter's big and bright, and Mars is still far away, but it's, I think you'll be able to recognize it. Mars will be quite red, and
Mm-hmm.
Jupiter will be that bright, creamy white color.
I'm going to move us over with the Blaze Star.
Oh,
I'm doing T-Core bore anyway because we don't need to do much with it. And then I'm going to redo the plate solve, which may not need to though.
yeah, if you have stellarium or something similar, and you can easily modify the date and the time, if you scroll over till 2 or 3 or 4 in the morning and get the head of Taurus the bull, the Hyades, and the tips of the horns in the field of view, start off now, today, and then click it forward a day at a time and keep watching. You'll see Mars creep closer and closer to Jupiter night by night until they're closest on the morning of the 14th. And I mean, they'll be, again, slightly more than half a lunar diameter apart.
Mm-hmm.
So they'll be pretty darn close. That should make quite a sight.
Yeah. Okay. We're going to have the star in question be right here. Let's get it in here. There we go. There's our Blaze Star. It's called a Blaze Star because it's a star that actually goes through this multiple times and has gone through it multiple times. And that's it right there. Let's minimize this for now and pull this over and ride up our black level curve.
Looking at the Nova watch today, it's magnitude 9.9. So it's actually brightened now. Maybe it's getting ready to take off.
Yeah, maybe so. All right, let's bring this up. And we'll save the image with annotations. The reason I'm actually doing this is because I have the capability of grabbing that star and looking at its spectrum. I can actually analyze its spectrum from our stream. I can extract that and check it out. So we'll be able to see the change in the star's spectrum when there's a nova. Hello. You know, so that's pretty cool. All right, what is this happening here? Let's go back to better quality.
Michael Hedrick said, I wonder when this last happened. I knew, but I forgot.
80 years ago.
80?
Yeah.
Yeah, something like that.
All right, so this is T-Core Bohr. Yes, don't just stop for now. You gotta type in the name. Excuse me.
Looks like you had a fortuitous satellite pass there,
I did.
or unfortuitous, depending on your point of view.
Yeah. Oh, shoot. I see what happened there. All right, there's gonna be a bunch of names up there. T core Bohr. All right. Don't know why it's doing that. I think my shift key is stuck. All right. I'm going to save this. Save exactly the scene. Okay. We got it. And now we're going to go back to our low light mode. All right.
Did you save
I saved that.
the pillars?
I did.
Okay, Carl Becker asked.
Yeah, I've been saving all of them. All right. Okay. Ray, thank you for the commentary on T-Core Bohr. Let's see where we are. Oh, yeah, look, it's already getting to the Milky Way. Okay.
Oh, it is coming fast.
I told you, man. Okay, so you guys get to watch this happen now. We're going to park the telescope here. And you see it move to its parked position. And I've got my telescope control program here. And the telescope here will tell us that we can shut off the power to the telescope. All right, you'll see that appear right here. Turn scope off. Okay. Telescope's now without power, and we can now close the roof. We can't close the roof until the telescope is parked. It won't let us. So there. There goes our roof. Okay. Excuse me. So what happens is now the roof is being closed 2,600 miles away from here. And it actually makes for a really good setup. Now, at the same time, I might be able to, while we're here, bring something up. Let me say not now. So I haven't tried this. Let's try it. SkyTour live.org. Here we are. So this is SkyTourLive.org. You can call us, you can email us, you can donate now, and if you look down, as you scroll down, it tells you the universe live in real time. The latest stream will be up here if you want to watch it. I'm actually working on embedding a live link in here, so you can just go to SkyTourLive.org to watch this. The AllSky camera, that's coming. I gotta get it set up. And if you say I want to see cool pictures, is here, go to the online database. It tells you what to do. Now, that's one way. The other way is to use our app. And our app is the coolest thing. And I'm going to show you that. And the app was written by Izabela, who is in the chat right now. Okay, and I will show you. Hopefully, I can do this here. I hope I did this. I don't know if I've actually gotten into it from here. I would have to log in. I think I can. If I log in with Google. Uh-oh. I think I'm here. Oops, at gmail.com. You don't... Oh, sorry. What's it doing? Oh, it is a shift key thing. Shift state
I thought it said MUFO anomaly at first.
Yeah. No, I'm having a shift state issue. I get the 2 key, and only 2 shows up. The shift isn't working. This happens sometimes with these keyboards. It's weird. How about this? No, I'm trying to get the @ sign, and it just won't come up. I have a stuck shift state. I hate when that happens. There we go. I fixed it. Okay. At gmail.com. Now, oh, that's really weird. Now I can't get the period. Oh, boy.
I think you're suffering Pepsi syndrome.
Which is?
You remember the Jack Lemmon movie, China Syndrome?
I do.
Way back in the day when that came out, Saturday Night Live made fun of it. They did a sketch called Pepsi Syndrome.
Oh, that's funny.
That somebody spilled a Pepsi on the computer control panels.
Yeah, I'm not going to be able to do it because I can't. The shift state's messed up on this keyboard, and I don't know why. Wait, I might be able to fix it, though. Let me try and fix it. All right, let's see if that actually worked. I can test that really quickly. And we can go here. I'm just trying to show you a few things. So if I... okay, DFDF. Yeah, that's good. So I think I'm good. Yeah, please hit that like button, guys. We did have to close, like I said. If you notice, when we go here at the AllSky, you see how that's moving in so quickly? We've already lost our Milky Way. And this is rain, so we have to be careful, very, very careful. All right, so we ducked out of the stream in time. We're all safe. Roof's closed. Now I'm trying to show you a couple additional things here. We're sorry. What is this? Oh, Firefox had a problem and crashed. Okay, and I get it. That's fine. So I might be able to do this a different way. If I do a left to right screen. Okay, so now let me try something here. I never say give up. I never give up. So let me do this, which you can't see. I'm gonna do this. All right, and okay, this will work. Haha. I win. Okay, here we go. All right, so looking here, this is if you were to view our application that you'll get to play with and enjoy. This is what you see. Okay, this is all the objects we've been doing for the last several years, and you go through and through and through. They're all updated, and what do you get? Well, let's say we take a look at, say, the Lagoon Nebula here. We click on it, and you'll see the Lagoon Nebula. We click on it again, and we get the full image of it, and we can even get bigger and move it around and check it out and look at it. You can download this image for free from here. All right, how? Well, that's easy. You just come in here, and let's say you go in here and you say ping file, and now it takes you to our website, and now you have the ping file right here, and you can then download this to your computer. All right, and it's really cool. All right, and there's a number of things you can do here. If you look down this left side, there's all kinds of things. We look at everything in a table format where you see lots of detail. Measure 16, the Eagle Nebula. That was observation 1760. And this was back on the 5th of July, 2024. We can click on it, and it comes up, and there it is. And it was done at 10:55 and 26 MST, Mountain Standard Time, at the STLS Western Observatory with that camera. 10 exposures at 200 gain, 42 images stacked. How does that look? Well, it looks like this. Right? It looks really pretty. All right? So it gives you a chance to do more than this too. That's just that. We can look at object types. Ooh, yeah. Let's look at planetary nebulae. And we look at this. Here's the description of planetary nebulae. And we can show all images with planetary nebulae. And boom, all the planetaries we've ever shot show up here. From the most recent to the oldest ones. You can compare. This is a way, for instance, to get all helix nebulas. You can actually search for all helix nebulae. All right, and so when we go back, okay, let's go back to, say, our gallery, and we search for the Helix Nebula. All right, helix. Well, here they are. Every helix that we've done in the last several years, are here. All right, 11/9/2023, back to 11/26/2021, right here. And you can then download all of these and compare to see if there's anything missing in these images. And that's what Izabela's been doing. And she has figured out that in some cases we're missing stars. The stars have vanished. All right. And in other cases, she catches asteroids that are going through the field and has actually identified them. So you see, there's a lot of things that are going for us by having all this previous data. Now, if we're done looking at the helix, we go back to our gallery, and we can say look for the Trifid Nebula over all the years that we've done it. All right, and here it is. It's the Trifid, and you'll notice in some cases there's way more. Now you might say, well, what is this doing here? Well, this is the Trifid Lagoon Chinese Dragon Nebula. And if you saw the latest Facebook post I made, it is this very mosaic, not this exact one. This is from 9/15/2022, as you see here. Okay, but what happened was we did a beautiful mosaic, and if we come up here, Trifid Nebula region east, Trifid Nebula mosaic. I started with Trifid Nebula, okay, and then we had a lagoon mosaic and Chinese Dragon mosaic. Okay, all here, and then the Trifid Nebula itself. Beautiful image, beautiful, stunning images. Look at this. You can learn a lot, okay, because you have access to a real astronomer, if you want, and he'll tell you all about this. That happens to be the stuff I like to do. I'll tell you all about these things if you want. And if Daryl's around, I'm sure he will too. So, bottom line is that this application is quite good, quite nice. Gives us plenty of things to look at and explore. But I wanted to thank you guys for coming out tonight. Hopefully, if you get to our SkyTourLive.org, if you want, you can donate to us. That'd be wonderful if you did. And if not, please just enjoy our freebies that we give out. If you're really interested in learning more about the kinds of things that we do and what we have to offer, When you go to SkyTourLive.org, scroll down more, see the past winners of equipment that we've given away. We're going to go back to doing that. All right. And then what you could do, in fact, is also go to our Etsy store, SkyTour Shop on Etsy. And in SkyTour Shop, you can see some really, really cool objects on mugs and all kinds of things, clothing. We have sneakers with nebulae on them that we shot, and they don't look bad. These are professionally made, really stunning looking. Several people here were really astonished by how beautiful, for instance, the Christmas tree cluster and associated nebulae look on an 80-inch blanket, a giant fleece blanket with the printing on it, and it's just a stunning, beautiful addition to a couch in a living room. It's just stunning, and or wrapped around you in a winter day. So, kind of cool. Anyway, I hope you guys enjoy. Izabela put up the Etsy shop for you if you want to see it. If you want to check that out, please do. You can find us at SkyTourLive.org. And as usual, I hope you guys have a really good night. And we will see you again, I am sure. So you have a good night. And remember, when you go out, keep looking up. All right?
Good night, everybody.
Good night, folks. One last view of our AllSky. Yeah, see that? It's coming in. It's coming in.
Yeah.
We're going in. We're going in full throttle. That ought to keep the fighters off our tail.
Fantasy mentioned the Perseids. Perseids are best the morning of the 12th, too.
Yeah, that's this month.
Yep.
Okay, folks. Next clear night, we'll have more time, I promise. All right, folks. See you later. I got to go before this storm gets upon us. Thanks. We'll see you all later.
Good night, everybody.
Good night.